Hello everyone, I'm Harini R from Sri Venkateswara College of Engineering, Bengaluru from the Department of ECE. Topic is Norton's Theorem. Norton's theorem, it states that it is the dual of Thevenin's theorem. By using Norton's theorem, any network can be converted in the single current source in parallel with single resistance of impedance. Statement: any linear bilateral network with output terminals A and B shown in figure A can be converted into a single current source in parallel with a single impedance across the same terminals A and B as shown in figure B. The value of the current source IN is equal to the short circuit current flowing through the load terminal, and the value of Norton's impedance Zn is equal to the total equivalent impedance of network measured from load terminal by making all the independent sources to zero, that is replacing voltage source by SE and current source by open circuit. Proof: consider the network as shown. From the proof of Thevenin's theorem, IL equals VR2 whole divided by R1 into R2 plus R1 into R3 plus R1 into RL plus R2 into R3 plus R2 into RL. This is the equation 1. Verification of the above equation by Norton's theorem. Now the step 1 is to find IN. Remove the load and short circuit A and B and find short circuit current. By using current division rule, IN equals R2 whole divided by R2 plus R3 into I. This is equation 2. Next, I equals V whole divided by R1 plus R2 into R3 divided by R2 plus R3 is equals to V divided by R1 into R2 plus R1 into R3 plus R2 into R3 divided by R2 plus R3. This is equation 3. Now substitute equation 3 in equation 2. In equals R2 divided by R2 plus R3 into V whole divided by R1 into R2 plus R1 into R3 plus R2 into R3 divided by R2 plus R3. Now totally it is In equals V into R2 whole divided by R1 into R2 plus R1 into R3 plus R2 into R3. Next, in step 2, we should find Rn. Make all the sources in the network 0 and find total resistance of the network looking in the terminals A and B. Here Rn equals R1 into R2 all divided by R1 plus R2 plus R3 equals R1 into R2 plus R1 into R3 plus R2 into R3 whole divided by R1 plus R2. Next, step 3. Write Norton's equivalent and connect load across AB. Here IL equals Rn by Rn plus RL into IN. IL equals R1 into R2 plus R1 into R3 plus R2 into R3 divided by R1 plus R2 whole divided by R1 into R2 plus R1 into R3 plus R2 into R3 divided by R1 plus R2 plus RL into V into R2 divided by R1 into R2 plus R1 into R3 plus R2 into R3. IL equals R1 into R2 plus R1 into R3 plus R2 into R3 divided by R1 plus R2 whole divided by R1 into R2 plus R1 into R3 plus R2 into R3 plus R1 into RL plus R2 into RL divided by R1 plus R2 into VR2 divided by R1 into R2 plus R1 into R3 plus R2 into R3. Here R1 into R3 plus R2 into R3 cancels and R1 plus R2 cancels. IL equals V into R2 whole divided by R1 into R2 plus R1 into R3 plus R2 into R3 plus R1 into RL plus R2 into RL. This is equation 4. So now equation 4 is same as equation 1. Hence now we have a problem. Using Thevenin's theorem, find the current flowing through 6 ohm resistor for network shown. Step 1. To find VTH, open circuit voltage, hence 6 ohm resistor is load, hence it removes. Remove 6 ohm resistor and find open circuit voltage across AB. Now 4I1 plus 4I1 is equals to minus 20 plus 4. 8I1 equals minus 16. I1 equals minus 2 ampere. VTH equals VA minus VB, where VB equals 0. VA equals VTH. VA equals 4I1 plus 20 minus 5 equals minus 8 plus 20 minus 5. So VA equals VB equals 7 volts. Step 2 includes to find RTH, make all the sources in the network 0. RTH equals 4 into 4 divided by 4 plus 4 plus 2. So RTH equals 4 ohm. Step 3 includes write Thevenin's equivalent. I equals VTH by RTH plus RL. I equals 7 by 4 plus 6, where I equals 0.7 ampere. Thank you.